VPD just stands for the vapor pressure deficit. And the deficit meaning like a difference. Inside a leaf, the water is liquid. Outside the leaf, any of the water that's in the air is in a vapor. So the more water that you put into the air, the more heavily saturated it gets, right? And so the difference in water pressure between the leaf and the air gets smaller as there's a lot of water in the air. And you can imagine going all the way to 100% where it's like literally raining and water's falling out of the air. And the less water, the less evaporated water that you have in the air, the drier that air is, then the bigger the difference between the inside of the leaf and the air, right? It's like having really, really dry air and then something wet. So it's causing this like really big gradient, this like, it's like a suction force pulling water out of the leaf. It's just saying the difference in vapor pressure between the inside of the leaf and the air. When the VPD is really high, that means the difference is really large. And that means that the air is hot and dry compared to the inside of the leaf. And when the VPD is really low, that means the difference is small and the air is like humid and cool compared to the inside of the leaf. The air is sucking water out of the leaf. And that suction out of the leaf causes also a suction up the stem, which causes a suction out of the roots, which brings up water and nutrients and things like that. But if the air is super dry and the VPD is like really high, then that suction is happening so fast that it stresses the plant out. And it's like, no, and it starts closing down those pores to try to protect its water stores. Since it closes those stomata where the water is getting sucked out, that's also the place where CO2 goes in. And if it stops getting CO2 from the air, it stops growing. That's the problem. And on the other side, you want the air to be dry enough that you have some suction force, right? Because if the air is super humid, then there's not enough suction power to pull water and nutrients up through the roots. It's trying to stay in the happy zone where water and nutrients are being pulled through at the right level and not too fast or too slow. As the CO2 levels in the air go up, it causes the stomata, those pores, to actually become like a little bit lazier. They like close a little bit because the concentration of CO2 is so high, they don't need to be as wide open to get everything they need. So if the CO2 level drops, then the pores get wider and wider and wider open because they're just like, oh shit, there's not enough of this in the air. We need to be wide open to catch every bit we can. And the side effect of that is that they release a ton of humidity out too. Just above a certain amount, it's not useful. And under certain conditions, like really dry air, having really high CO2 can cause further plant stress. So that's the basic caveat there.